Hello, everyone, and thank you for clicking through to my presentation today. I'm Rzodkiewicz, and I'm going to be talking about some of my master's thesis work in Central Michigan University. Now, contaminants of emerging concern are a broad class of chemicals that are not yet defined in their effects on aquatic life. We know that they're out there, but we're not sure what they might be doing. This can include anything from our sunscreens to our pesticides and pharmaceuticals, and the effects can be widespread from behavioral modification to direct toxicity to our organisms. Now, what we were hoping to accomplish is to investigate these in a partial life cycle test of Lampsillus cardium, wherein we would be testing effects on our adult mussels, Glaucidia, their host fish, and their transition to juveniles on those host fish that had been exposed to the same contaminant. Today, I am simply going to focus on that transition rather than speaking about any of the changes to the adult stages or any of the effects on the Glaucidia themselves. Now, why focus on this particular transition? Well, this could lead to population level detriment. If we do not see Glaucidia metamorphosing into juveniles at the same rate as we did previously, populations may become unstable as we no longer have the same contribution to later adult stage classes. So today, I'm first going to summarize a bit my empirical results. What did we see in our lab study? And then we're going to take it a step further. And we're going to apply those results to population projections and ask what might happen in field if formerly pristine rivers are exposed to these contaminants of emerging concern. What would we anticipate as an effect on our unionics? To accomplish this, we use synthesized CEC contaminant mixtures that were determined from a widespread survey across the Great Lakes Basin. Now, these mixtures were present at low, medium, and high concentrations, where a medium is the highest measurement of that concentration in nature, a low a tenfold diminution, and a high a tenfold augmentation. Here in the chart, I'm showing you those medium concentrations. So one of the more ecologically relevant contaminant mixtures. Here I'm showing the agricultural land use treatment in green and our urban land use in orange. This color scheme is going to carry throughout the presentation. Now, I don't expect you to pay attention to those exact numbers and the exact concentrations in that chart, but what I do want you to note is that we did have certain CECs that were consistent and ubiquitous across land use. So 4-nonylphenol, BPA, DEET, estrone, and TBEP were found regardless of land use, just to give you an idea of how ubiquitous these CECs truly are. Now, these mixtures were applied to both our host fish, Micropterus salmoides, or largemouth bass, as well as Lampsillus cardium. These organisms also were exposed to control treatments, either a control water, so just business as usual, same water we'd always put in our flow-through systems, or a solvent control. Ethanol was the solvent carrier of our contaminants in our CEC mixtures and was thus used to elucidate any potential effects that might be having on its own. These exposures occurred for one of two durations, either a long-term duration of 100 days or a short-term, about 40 days. Midway through, we performed infestations, wherein midway through, we performed infestations using standard protocol, wherein the marsupial gills were flushed, Glaucidia were tested for viabilities, and added to our host fish tanks, with filters placed on the back of each tank after infestation occurred to allow us to quantify their contents every other day for the duration of the experiment. Now, the contents of these filters were noted as either containing Glaucidia, juveniles, and those juveniles were then subdivided into partially or fully metamorphosed. After we collected this data, I realized I was going to have some options on how I wanted to calculate the impact on transformation our CECs had. Now, traditionally, a lot of folks will calculate transformation simply as a percent transform. Number of juveniles we got off that fish over number of Glaucidia we put on that fish. Unfortunately, this relies on having a pretty good estimation of how many Glaucidia attach to the fish. Given the high densities used in the study, that simply was not feasible, and I began to search out alternatives. I came across two alternatives that had previously been used to describe juvenile transformation in unionids or related mussel species. First, I came across our generalized linear mixed effect models, wherein I could track both our individual host fish and the larval response, or alternatively using a time response curve. When I say time response curve, I mean something very similar to a dose response curve for those of you who work frequently in ecotox. Instead of our x-axis being represented by increasing toxicity, however, here we're simply going to describe it as time, and our y-axis being the response, in this case, juveniles dropping off. To avoid getting too much into the statistical weeds today, I'm going to focus on those time response curves and then mention how these results were confirmed using a zero inflated Poisson distributed GLMM. To construct our time response curves, I was unfortunately only able to use our long-term exposure data. What this means is I had to truncate my data set to fish who survived for greater than 30 days. I chose to do this to be able to describe the entirety of juvenile drop-off curves. So from an initial lag phase where Glaucidia are encysted, to their increase, peak day drop-off, and then coming back down after most Glaucidia had transformed or been sloughed off. To describe these curves, I fit a variety of our host fish using the MATLAB curve fitting tool to get an idea of what our best fit would be using the R-squared value. I found the best fit to be a third order polynomial and moved forward fitting those curves for each individual host fish, resulting in a graph that looks a little something like this, where you're looking at our controls for water in blue, ethanol in red, our agricultural treatments in green, with agricultural medium being a lighter green than ag high. Agricultural low, unfortunately, had to be omitted from this analysis due to low survivorship during our long-term trials. And lastly, we had our urban treatments shown here in orange, where urban low is going to be our lightest color, urban high our darkest. I then took these curves and I calculated the critical point. The critical point being where our slope is at 0, nothing is changing, we're at the tip top of those curves. Using the coordinates of this critical point, I was able to determine the peak day when the most juveniles were dropping off, as well as the number of juveniles that dropped off at that day. When I compared these, I was able to find some general trends. We had fewer juveniles that transformed across our CAC treatments, and there was a shift towards a longer period of encystment in those CAC treatments as well. Now here I want to note that I was able to confirm those trends using my zero inflated Poisson generalized mixed model and compare between our short and long-term treatments, as here I wasn't interested necessarily in fitting the entire curve. In this case, I was able to identify that the short and long-term treatments mirrored these trends exactly. And what I mean by that is it didn't matter if it was a 40-day exposure or a 100-day exposure. We saw these same trends. Now, what I've discussed so far is all just our empirical results. So let's take it a step further and start talking about those population level impacts. To do this, I used a Rzodkiewicz stage-based model. What this means is I was able to divide our populations up into classes of Glaucidia, juveniles, subadults, and adults. And then I was able to parameterize the transition, so the survivorship from Glaucidia to juvenile, subadult, and so on, as well as the contribution of the adult classes to the next generation, so their fecundity into that Glaucidia stage. It's necessary to note that I broke up juveniles into 2 years, given the age till maturity of Lampsill's cardium, and the adult group into 10 stages, given the length fecundity relationship in unionids. The circled arrow here represents the transition that I'm going to apply some of my data to in just a minute. I was able to parameterize this model through mining the literature for either exact parameters of life history components related to Lampsacillus cardium or components related to highly related species that we know are similar in life history parameters. After I completed this parameterization for our control population, I then modified this data using the percent reduction I saw between a CEC treatment and the control water. Using this, I was able to alter the parameter for that transition from Glaucidia to juvenile to reflect the reductions in transformation expected under CEC conditions. Now, there are a lot of advantages to this technique. It allows me to project forward in time, address the growth rate, as well as perform two different types of analyses. So to address the elasticity of my model, so what component is going to have the greatest change on lambda based on absolute numbers, and sensitivity, which is which parameter is going to have the biggest effect on lambda based on their proportional change. So think about that one as more percent change, where elasticity is just if we bump it up one, what happens? When we complete these projections for control water, we see this great stable population. We have a lambda just above 1 representing population growth. However, when I overlay the CEC treatments using the same color schemes as before, what we're going to note immediately is lambda for all of those treatments is going to be under 1. And if we dig in a little further, we can look at those elasticity and sensitivity analyses. Now, for all groups, the most elastic component is going to be survivorship of our oldest adults. And our sensitivity is for all groups is going to be our Glaucidia survival to juveniles. However, our sensitivity for that Glaucidia transition to juvenile over doubles between our control water and our nearest population of agricultural medium, showing the impact of effect that really has, that reduction in transformation can have on our population. Now, of course, there's some caveats we should discuss here. This is only showing the effects of one type of stressor, CEC mixtures, in one species, and doesn't necessarily account for temporal fluctuations in that CEC concentration throughout the year. This also doesn't account for any demographic stochasticity. This modeling type did not include that. However, I do think there's some valuable information we can glean from management efforts here. For example, this study really shows us the importance of studying these crucial transitions for what might be our population level effects. And furthermore, it helped us to identify 2 life stages that are particularly vulnerable: Glaucidia survivorship to juvenile and our survivorship of our oldest adults, and thus their fecundity to the next generation. While we may not be able to eliminate all CECs given their number of point and non-point non-point sources, we could potentially address things that are affecting adult survivorship. We may be able to limit sedimentation and other point source pollution, things that are affecting our large-bodied adults directly. Additionally, this study has really demonstrated the power in combining our empirical results with those in the literature and demonstrates the increased need for these population-level studies. Now, before I take off and hopefully answer some of your awesome questions later on at our Q&A session, I do have a few acknowledgements. Of course, my co-authors, Dalen Woolnough and Mandy Yanis, as well as the whole Woolnough lab at Central Michigan University, particularly members of my cohort, Steph Gill and Justin Rappold, for all of their hard work on this project. I want to thank you all for listening, and I will be glad to take any questions later, or if you need to reach out to me by email. Thank you.